One important point that I forgot to mention in the previous class is regarding the scale of the cam profile. I hope you understood from the last class that I had followed a 1:1 scale. It depends upon the space you get to draw the cam profile. So if you have enough space to draw, take 1:1 scale, then you can follow that, or otherwise you can reduce the scale. Also, in some cases, maybe if you when you draw according to 1:1 scale, the drawing may look very small. So in that case, you can increase the scale also. You can go for 2:1 scale. So the scale depends upon your space availability. So I hope you understood that. In the last class, we had discussed about how to draw a cam profile for a knife edge follower, which undergoes outward stroke and return stroke according to a uniform motion and simple harmonic motion respectively. Now in this class, we will discuss a modification of that particular problem. Here the type of motion of the follower will be the same. The difference will be the type of the follower. Also, I would want you to think over the direction of rotation of the cam in the previous question. Cam can rotate in two directions, either in the clockwise direction or in the anti-clockwise direction. So according to the last question, according to the way in which we have drawn the cam profile, can you find in which direction does the cam rotate? So when you are submitting the notes to me, you please specify that in your note. In today's class, as I told you, we will modify the previous question a little bit. We will try to change the type of follower and the alignment of the follower, and we will see how it will affect the cam profile. So I will read the question. The second question. A cam is to give the following motion to a roller follower: outstroke during 60 degree of cam rotation, dwell for the next 30 degree of cam rotation, the return stroke during next 60 degree of cam rotation, and dwell for the remaining 210 degree of cam rotation. The stroke of the follower is 40 millimeter, and the minimum radius of the cam is 50 millimeter, and the diameter of the roller is 30 millimeter. The follower moves with uniform velocity during the outstroke and with a simple harmonic motion during the return stroke. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. When you read the question carefully, you will understand that comparing the previous question that we did, the only difference that you will find in this question is the type of follower used. In this particular question, the type of follower used is a roller follower compared to the knife edge follower that was used in the previous question. The other details regarding the type of motion of the follower and the way in which the cam angle is divided based on the type of motion of the follower are all the same. Like here, you have the outstroke takes place at an angle of 60 degree of cam rotation. First dwell period takes place for the next 30 degree of cam rotation. Return stroke takes place during the next 60 degree of cam rotation, and the dwell period for the remaining 210 degree of cam rotation. These details are same as that in the first question. Also, the outward stroke is as per uniform velocity, and the return stroke is as per the simple harmonic motion. It is also given that the axis of the follower passes through the axis of the camshaft. So here also we are going to deal with a radial cam follower arrangement. Since the type of motion of the follower is same as that in the first question, there is no need to draw the displacement diagram of the follower again. We can use the same displacement diagram that we had drawn in the first question. The only change will be coming in the cam profile due to the change in the type of follower that is used. So we will now discuss how to draw the cam profile in detail. So here, like in the first question, first you need to draw the base circle. The base circle radius is given as 50 millimeter. So with a radius of 50 millimeter, that is 5 centimeter, you draw a circle. That will be the base circle. Now with the same center, you need to draw the prime circle. The prime circle radius will be the sum of the base circle radius and the radius of the roller. In the question, it is given that the roller radius is 30 millimeter. So the prime circle radius will become 50 plus 15, that will be 65. So you draw a circle of radius 65 millimeter with center O, and thereafter from O you draw a vertical line which meets the prime circle at A. Now most of the procedure will be similar to what we had done in the previous question. As you know, the point A is known as the trace point. Now, like in the previous question, you need to divide the circle into the various follower motion regions. So you need to take an angle of 60 degree with OA as the base, and you draw a line from O. So this region will be the outstroke region, and then with the new line you draw an angle of you take an angle of 30 degree and draw another line. That will be the first dual period region, and then with the next new line, with respect to the next new line, you take an angle of 60 degree, and from O you draw a line, and that region is the outward stroke in return stroke region, and the rest of the region is the second dual period region. You need to label the intersecting points of the lines with a circle. Like here you have C, here D, here E, like we had done in the previous question. Now what you need to do is, I hope all of you know it, you have to divide the outstroke region and the return stroke region into 6 equal parts. That means you need to take an angle of 10 degree, and you need to make the division. You need to make the divisions on the outstroke as well as return stroke region, and also you need to label the intersecting points. You need to label the intersecting points with the circle, that is 1, 2, 3, 4, 5, 6. Similarly, in the return stroke region also, you need to label the intersecting points with the circle, that is 6 prime, 5 prime, 4 prime, 3 prime, 2 prime, 1 prime. you please be careful that and also please note that these points lie on the outer circle. These intersecting points lie on the outer circle. After dividing the outstroke region and the return stroke region, and also after labeling the intersecting points, now what you need to do is, like we had done before, you go to the displacement diagram. So the displacement diagram is the same as that we had drawn for the first question. In that displacement diagram, you measure the length 1a in the compass. You measure the length 1a in the compass, and now with 1 as center, you mark a arc on this line. So that will be A. Similarly, so this thing we have already done, so I am not repeating it. Similarly, you go back to the displacement diagram, you measure 2b in your compass, and then come here, and with 2 as center, you make an arc on this line, that will be B. So similarly, you complete the whole thing, that is, you take the measurements for the outward stroke as well as for the return stroke, both. After taking measurements from the displacement diagram and marking it in the cam profile, now what you need to do is, you need to join these points by free hand, like you had done it before. You join these points starting from A and capital A and connecting with its small letter A. Likewise, you join all points. Similarly, from E to A prime, then B, C prime, D prime, E prime. Like in the previous case also, F prime and F can be joined using a compass with O as center. And also, you have to join this, thicken this circle also. So likewise, you get a profile which is known as what? This is not the cam profile. What you have drawn now is not the cam profile. This profile is known as the pitch curve. From the pitch curve, now we need to draw the cam profile. You might have understood now that if it is a knife edge follower, pitch curve will be same as the cam profile. But in the case of a roller follower, pitch curve and cam profile are different. First, you draw the pitch curve, then from the pitch curve, we get the cam profile. Now we will see how to get the cam profile from the pitch curve. Now what you have to do is, from point A, that is capital A, which is the trace point, with A as the center, you draw a circle. The radius of the circle will be the radius of the roller. That means the radius of the roller here is 15 millimeter. You draw a circle of radius 15 millimeter. Similarly, you draw circles from point A, B, C, D, E, F, F prime, E prime, D prime, C prime, B prime, A prime, and E prime. From all these points, at all these points, or as all these points are centers, you have to draw a circle of radius 15 millimeter. Now you can see here that I have drawn the circles at all those points. Now what you need to do is, we need to join all the lowest points of those circles. So starting from this point, you join all the lowest points of those circles. Also, you have to take the part of the base circle. So now this is our cam profile. Okay, so this is our cam profile when it is a roller follower. So here also, you please think over what will be the direction of rotation of the cam for the given motion of the follower. Now this is the third question that we are going to discuss regarding the cam profile. I read the question. A cam is to give the following motion to a knife edge follower: outstroke during 60 degree of cam rotation, dwell for the next 30 degree of cam rotation, return stroke during next 60 degree of cam rotation, and the dwell for the remaining 210 degree of cam rotation. The stroke of the follower is 40 millimeter and the minimum radius of the cam is 50 millimeter. The follower moves with uniform velocity during the outstroke and with a simple harmonic motion during the return strokes. Draw the profile of the cam when the line of the stroke of the follower is offset 20 millimeter from the axis of the camshaft. When we read the question, you will understand that this is similar to what we had done before. Here the type of follower is a knife edge follower. The motion of the follower is the same, and the type of motion is also the same. That is, the outstroke is based on uniform velocity and the return stroke is based on simple harmonic motion. The only difference in this question is regarding the alignment of the axis of the follower and the axis of the camshaft. Here the line of stroke of the follower is at a distance of 20 millimeter from the axis of the camshaft. Here we are discussing about a offset cam and follower arrangement. Now that means, since the motion of the follower and the details regarding the follower are all the same, we can use the displacement diagram of our first question. The only change will come in the cam profile that we draw. So now we will discuss how to draw the cam profile in the case of a offset cam and follower arrangement. The procedure to draw the cam profile of this particular question has a slight difference to that of the first or the second question. That is, you can discuss in detail. First, you need to draw the base circle. The radius of the base circle is given as 50 millimeter. First, you draw a circle of 50 millimeter whose center is O. Then after that, you have to draw another circle which is concentric to the first circle, whose radius is the offset distance, and that circle we call it as the offset circle. In the question given, the offset distance is given as 20 millimeter. That means you need to draw a circle with center O of radius 20 millimeter or 2 centimeter. After drawing the offset circle, you need to draw a vertical line from the right quadrant of the offset circle. This is the right quadrant. This is where the right quadrant will be. from that point you draw a vertical line such that it touches the base circle at A. This is one of the variation in the procedure to draw the cam profile compared to the questions that we had done before. As you know that A is the trace point. Now we will draw the cam profile based on the trace point. Now what you need to do is you need to join OA. You need to join OA, and then with OA as the baseline, you need to divide the base circle into the 4 different regions of follower motion. That is what I had done it here. I have joined OA, and then taking OA as the baseline, I have divided the base circle in terms of the 4 different regions of motions of follower. That means AOC is the outstroke region, COD is the first dwell period region, DOE is the return stroke region, and EOA is the second dwell period region. These angles are the same as before. There is no change in that. After dividing the base circle into the various regions of the follower motion, like before, we need to divide the outstroke region and the return stroke region into 6 equal parts. Now, while dividing the outstroke region and the return stroke region into 6 equal parts, there is a small change in the procedure. What you need to do is you have to mark the divisions onto the periphery of the circle. That means when you divide, for example, when you divide the region AOC into 6 regions, that is with respect to line AO, we take an angle of 10 degree. So with respect to line AO, you take an angle of 10 degree and then mark that point, 10 degree point, onto the base circle. Okay, mark the point on the periphery of the base circle and name it as 1. And similarly, you take an angle of 10 degree next and mark the division onto the periphery of the circle. Okay, and name it as 2. Similarly, you do the division for the outstroke region and the return stroke region. When you do the division, it will be something like this. I will just show how you notate it. So this point, that will be 1, this point will be 2, this point will be 3, this point will be 4, this point will be 5. Okay, and this will be C will be 6. Similarly, so that means you make the divisions on the periphery of the circle. Okay, similarly on the return stroke, you make the divisions 10 of angle of 10. So this will be 6 prime. Sorry, this will be 6 prime. This will be 5 prime. Then 4 prime, 3 prime, 2 prime, 1 prime. So like that, you make the divisions on the periphery of the circle. So now assume that this is the first point. So that is 1. This is 2. Next is 2, and 3, 4, 5, 6. Okay, and here on the return stroke it will be 6 prime, 5 prime, 4 prime, likewise. Okay. Now from 1 you have to draw a line such that it is tangent to the offset circle. So that means touching point 1 you draw a line such that it is tangent to the offset circle. Likewise, you can extend this line outside the base circle. Similarly, from 2 you draw a line such that it is tangent to the base offset circle. Also, you extend the line beyond the base circle. Similarly, now from point 3 you draw a line tangent to the offset circle. Okay, so in this way you do it, then you will get like this. Okay, so similarly at the return stroke region also you have to draw lines tangent to the base circle. Now 6 prime, from 6 prime you draw a line tangent to the base circle, offset circle, only thing that you need to be careful is that you need to extend this line beyond the base circle, like what I have done here. Okay, so you do it like this. After drawing all the tangents from the periphery of the base circle to the offset circle, you go to the displacement diagram like before. You take 1A in your compass, and then with 1 as center, you draw an arc on this line. So that will be A. Similarly, you go to the next point, that is you go to the displacement diagram, you take 2B in your compass, and then with 2 as center you draw an arc on this line. So that will be B. Similarly, you complete the whole thing, that is in the outstroke region and the return stroke region. And once you make all the measurements and mark it onto this diagram, after that you join all these points starting from A to small a, then B, C, D, E, F. Similarly onto the return stroke side, starting from capital E, A prime, B prime, C prime, D prime, E prime and F prime. Okay. Now here also you join F and F prime. Okay. Now here you cannot join F and F prime by using compass with center O, because it is not a circular profile. You need to join it using freehand. Okay. So in this way you draw the cam profile. So this is the cam profile for an offset follower. Okay. So that is the end of the 3 different types of questions. Now we will do one more question. We will solve one more question with another 2 types of motion of the follower. For that particular question, I will draw only the displacement diagram, or I will show you only how to draw the displacement diagram. The cam profile you need to draw. Okay. So that we will do in the next class.